Good day, students. My name is Mrs. Ukemi. You are welcome to our today's online lesson. Hope you are fine. Our topic today is binary system, and we'll be talking about different types of number bases. So, let's start with base 10. 4,956. 4,956. The place value of 4 is 1000. The place value of 9 is 100. The place value of 5 is tens. And the place value of 6 is units. This type of counting is in base 10. This type of counting is in base 10. So this can be further broken down as 4 times 1000 plus 9 times 100 plus 5 times 10 plus 6 times 1. 4 times 1000 means 4 times 10 raised to power 3. And 9 times 100 means 9 times 10 raised to power 2. 5 times 10 means 10 raised to power 1. And 6 times 1 also means 6 times 10 raised to power 0. A number raised to power 0 is 1. That is why we have 6 times 1. And then 10 raised to power 1 means 10. And that is why we have 5 times 10. 10 raised to power 2 is 100. That's why we have 9 times 100. And 10 raised to power 2 is 1000. That is why we have 4 times 1000. So 4,956 is this. And they are all written in base 10. This number means base 10. So apart from base 10, we have other bases. We can count in base 5. We can count in base 20. We can count in base 2, base 7, base 8, any base that you wish. So let us count in base 5. Is 5. 342 base 5. 342 base 5 means 3 times 25 plus 5 times 4 times 5 plus 2 times 1. So this means 3 times 5 raised to power 2 plus 4 times 5 raised to power 1 plus 2 times 5 raised to power 0. So the easiest way to know how to raise your powers of 5, you can just write, since it's base 5, you can write 5 times and 3 times 5 plus 4 times 5 plus 2 times 5. So starting from 2 times 5, you put 0 at the last 5. So raised to power 0. So after that is raised to power 1. After that one is raised to power 2. So that means the number is up to 1000. It will be raised to power 3. If it is tens of 1000, it will be raised to power 4. If it's hundreds of 1000, it will be raised to power 5. Well, here we just have 100. So it's raised to power 10. It will be raised to power 0, power 1, and power 2. So we know that 5 square is 25. 5 raised to power 1 is 5. Then 5 raised to power 0 is 1. So 342 base 5 means 3 times 25 plus 4 times 5 plus 2 times 1. So this way, this 342 subscript 5 is a short form of 342 in base 5. So we have 149.5. So that is 1 times 20, 1 times 25 plus 4 times 5 plus 9 times 5. So that is 1 times 5 raised to power 2 plus 4 times 5 raised to power 1 plus 9 times 5 raised to power 0. Counting in base 8. 320,745 in base 8. So we can expand it this way. 3 times 8 raised to power 5 plus 2 times 8 raised to power 4 plus 0 times 8 raised to power 3 plus 7 times 8 raised to power 2 plus 4 times 8 raised to power 1 plus 5 times 8 raised to power 0. So this one is 8. This 1, 2, 3, 4, 5, 6. There are 6 digits, and when we start counting from 0, we have 5 times 8 raised to power 0, 4 times 8 raised to power 1, 7 times 8 raised to power 2, 0 times 8 raised to power 3, 2 times 8 raised to power 4, and 3 times 8 raised to power 5. So that is the expansion. So expand 348 to base 8. Expand 348 base 8. 3 times 8 raised to power 2 plus 4 times 8 raised to power 1 plus 8 times 8 raised to power 0. So that is expansion of base 8. Then counting in base 2. 11101 base 2. 11101 base 2. This means 1 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. So you notice something, that when we are expanding a number in base 2, we multiply by 2 and raise to the powers. Then when we are expanding base 8, multiply by 8. When we are expanding by base 5, multiply by 5. So when you are expanding by any number, any number base, you multiply by that number, then put their powers according to the place value of the numbers. So these are your assignments. Expand these numbers. This one is base 5, this one is in base 4, and this is in base 8. I wish you good luck. In our next class, we talk more on binary 16. Thank you and have a wonderful